Okay, so what Randy's doing is he's actually got the end par, and he's kind of trying to fabricate in his mind where he wants to set it at.
See if I just made these boxes a lot shorter than it would have been able to come right in through with the door. Kind of keep them out of the door, but that's not going to happen. As you can see, it's taller than the plate that sits there.
Yeah, just too tall. It's going to be close. Now, if all goes well, we should start seeing data as soon as I plug it in. Randy, look. Check it out.
Yeah.
Now, we don't have any tubing connected, but it's connected to it, so it's going to pick up some acoustics. So right now, this will pick up. We don't have our tubing correctly, but it will pick up acoustics accordingly. Let's see if it pops up automatically. It popped up. Look at this. I coded it right. So we coded it right. We're running off 5-volt battery. There it is. Look at it. Look at it. Okay, so there's a pin on voltage in. So as you guys can tell, what we're doing now is we're basically we've got the installation, the upgrade completed for the data logger and the NPAR, Randy's data logger and the NPAR number 2. Here's your data logger with the sensor on it. I've not glued, I've not done anything with it, but it is working good. I will show you real quick here in just a second. Here's some of the code that we were trying to do that we got finally accomplished. But behind it, as you can tell, there's a date, 58 degrees, blah, 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 969, 28, all these. All right, what we're doing now is we are trying to clean this up a little bit. But SparkFun has done an amazing job of supporting us. We appreciate them very, very much. I cannot tell you how much we appreciate SparkFun Electronics and what they have done for us. Breeze, I can't tell you guys how much I appreciate you. Microsoft, everybody else that's been helping us, we appreciate you and value you, and we hope that this season is going to go well. Okay guys, so we actually had to pull out our pinout real quick to actually look for our another 3.3 volt source and a ground, because I wanted to put a LED on the case of this so that we would know that it is operating as it should be. So I soldered that in, got that in, and got the resistor, the pull down. I'm pulling it down roughly to about 2.9 volts, 2.8 volts, but admittedly that it's going to work. So what we're doing now is we've got our LED in, and we've got our sensor in. We've got everything prepped. It is coded, and we are flashing this onto a backup SD card, as you can tell. So we're copying the partitions right now for this particular data logger, and that's what we're going to do here.
Put your finger right there and hold that down square. Here we go. This is how she slides in. Oh, isn't that, man, that is like somebody knew what the hell they were doing for a moment.
That's right.
Look how tight that fits.
That's what
I don't even have to put the backstop on that. Shoot, that's going to hold that.
You think so?
Oh, yeah. As tight as that went in.
All right.
Pink.
That's what she said. Randy Hicks, the tornado guy.
Why did that one get tighter all of a sudden? Oh, well. Ain't going to come out, is it?
No. Okay. What do you think?
Progress.
I'm painting the inside of the probe. When I say inside, this is just the inside of the cover. The bottom. Randy's just painting it to cover it up a little bit.
No, I just like the hydrofluorocarbons myself.
Peyton just showed up in the Tornado Pursuit vehicle. Funnel Patrol, bitches. That's right. I forgot. That's on the back of it, isn't it? In funnels we trust. Yes, that's a Storm Chaser Street. Right there, babies.
Rock on.
Rock on. Yeah, I picked it up. See.
Oh, like the pressure port?
Yeah.
Right
They just wave it. Just, there you go. Look. Look at your hand. See? See what I mean? Okay, so you got pressure, you got temperature, humidity, altitude, blah, blah, blah. You got all that. So we've got the drone open here, and what we're doing here is we're looking at a 5-volt supply right in there, if you guys can see it. I believe that's a 5-volt supply. We'll get a voltometer and test. But ultimately, we're going to put the pressure sensor inside, so it's housed. Well, we wrote our code correctly. Yeah. And these are the results of the code of this particular chip. So we are actually doing really good. As you can tell, it's about, it was pretty warm, and then turned the heater down, and we're roughly at about 50, about 60 degrees or so. As you can tell, we are using the BME 280, which is a wonderful, very, very accurate sensor, pressure, altimeter, so forth and so on. And all of these are Bosch. Bosch is very accurate. Randy's is a little bit different, Junior compared to Cyclops, in that this particular sensor is a little bit blue, but in color, but pressure, temp, humidity, and altimeter. But and you guys can kind of see that. But I have got a mess like Hades around here. You guys see the wire from the super glue to the LiDAR, soldering, the whole 9 yards. And we're trying to get this thing done. But there's my probe with the NPAR to it, and this one has got our bleeder here accordingly, and that's it. We're gonna do this one way or the other. We have had our Arduinos from SparkFun. We went ahead and purchased some of that stuff, and of course you guys can tell down there, Kenny Kit and SparkFun, but most particularly I want to give a big shout out right now to SparkFun, Breeze, and Microsoft. You guys have done a wonderful job. This looks messy. Come severe weather season, guys, where hopefully this will be out in the field, and these probes will be ready to go, and our balloons and the drones and all that. So stay tuned. Took the lead off, put hot glue here so this wouldn't get shorted out. Antenna goes right here, so your bar will go right here. There's the end par working, and then if I go up to File and go to Sensor Logs, there's your BME 280. So right now it is, I don't know, 311. Yeah. 2111 UTC 29. So it's doing it every second, right? So showing 88 degrees in here. That's a little bit warm. That's because my hand was on it. So we'll see if that temperature remains. Glue here so this wouldn't get shorted out. Antenna goes right here, so your bar will go right here. There's the end par working, and then if I go up to File and go to Sensor Logs, there's your BME 280. So right now it is, I don't know, 311. Yeah. 2111 UTC 29. So it's doing it every second, right? So showing 88 degrees in here. That's a little bit warm. That's because my hand was on it. So we'll see if that temperature remains. Hey guys, kind of a quick update. It's about 4 o'clock in the morning and we have been writing code all night. About 20 hours working on various projects. We have this data logger now, which is our Pi, but we're going to be using it for a data logger. And then of course we've got the sensor, one of the sensors hooked up. We have our GPS unit here that is now working, and of course we have our other data logger with the GPS now upgraded, working fine. Conversely, we have this data logger upgraded and working fine. I am still in the process of trying to upgrade this data logger. Consequently, it's just on a breadboard. That will not remain that way, but that's what we're doing right now. You guys can see all of our SparkFun equipment and some of the stuff we've ordered in from Amazon, the can of kits and stuff. But I want to give a quick shout out here to SparkFun directly. We want to thank you guys so much for everything you've done for us. No doubt about it. You guys have blessed us immensely with the wish list, and then consequently the support you guys have given is unbelievable. So, full weather station right there, but of course these will go. That will go in Cyclops. The Cyclops probe. This one will go. This data logger will go in par 1, my NPAR. I'm sorry, this will actually go in Junior, not Cyclops. This one will go in Cyclops right here. This one right here will hopefully go in a 4th or 5th probe. And we do have an Arduino here that we are toying around with for the robotics. I'm contemplating a robot. We also, and I'm not going to turn the camera on me because I look like hell, but I mean it's 4 o'clock in the morning. But to make this video short and sweet, we also got all of our other equipment in. I think we're set for right now. this was quite expensive, and we're going to be trying to employ that accordingly for the Pacritex mission and Pacritex an outlaw mission for 2018. You can see some of the data on the screen here. The data, I'm not going to get too detailed with it. At temperature, humidity, temperature, humidity, pressure. That's the big key here. That's what we're wanting to do. We've named that incorrectly, but that's okay. We'll fix it. So, with that said, there you go, guys. This is it. I know it's a mess. I've got my stuff all over the place. So, but I want to thank you guys for watching. Consequently, I want to thank Spark Fun, CanKit, Microsoft, and Breeze. We also got I don't have the drones in here, but I also have the drones. I actually got one of the sensors wired to the GPS of the drone, so now we can get temperature, humidity, blah 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 from the drone itself. I flew that today and got that about at 105 foot, so we did good. Again, Spark Fun, I do appreciate you folks. You guys are awesome, and I cannot thank you all enough. Okay, guys, we're we're outside, and obviously we're looking at the van here, one of the vans. Obviously, we run this for the tours, but conversely, we do run it for Pacritex as well. And I wanted to make a key note that obviously we will not just be using the probes to deploy. Obviously, we're going to be using the balloons possibly, and of course the drones definitely, but also we will have this as a mobile Mesonet vehicle, a true mobile Mesonet vehicle. As you guys can see, we'll have temperature, humidity, wind speed, direction, the whole 9 yards. After we deploy the probes, of course, we'll have this particular data very close to the tornado as well, not just inside of it. So after we drop the probes and or the drones, fly the drones and get the pressure perturbations and so forth, we will actually have this particular data as well. We want to thank Lacrosse Technologies. That's their device, and certainly they supported us, so we thank them immensely. That said, guys, Pacritex 2018 is a go. Now we've run into some difficulties, I'm not going to lie. Lisa's not doing very well at all, and she's such an integral part of this team and such an integral part of Outlaw Chasers. And so, well, to be frank, it's difficult. She's not doing well at all, but we're going to continue the mission and as she would want, and hopefully we will be able to obtain some real true scientific data and some scientific data that the scientific community has not received yet. For an example, the drone height from 0 AGL to 300 feet in and around supercells and or tornadoes. We want to get the pressure perturbations and so forth and so on. We've got that availability to us now. We're working on the balloons. That's the last step. So we're just about done. All right, guys, stay tuned. Pacritex 2018, hashtag it. We're in there. Pressure acoustic recording inside tornadoes experiment. Randy Hicks, Lanny Dean, Lisa McGeough, Peyton Nichols, Pat Wynn, David Moran, Chris Rice. We appreciate everybody, all the support that we've gotten from Microsoft, Breeze, Lacrosse Technologies, more importantly and most importantly, Spark Fun, because you have done us a wonderful job and we thank you. We're about done. We're not far from it. It'll kick off pretty soon.